Hi class. Today we're gonna be working on the labs that we have. They're gonna be due on Friday lecture time. We don't have class on Wednesday, so what we're gonna be doing is we're gonna have two labs that are due on Friday. I'm posting the labs on your on our core courses right now. I forgot to do it. But I'll be posting the two labs that you have to do. One of them is the four inputs plus one minus one, and labs that will be lab 14 and 15. I'll just give me a second, and I'll put them right now. That way you know which ones exactly you have to work on. Oops. Lab 14 and submission type. Nope. And then grade and module, choose a file, downloads, open for input plus one. Upload this file, and this is due on Friday. Friday the 13th at 1:30. 1:30 p.m. Okay, so I've submitted I posted the first lab. Lab 14 is the four input plus one lab. That one should be fairly simple. I'll show you guys my work so that way you have an idea. And also you have to do the adder one, which I'll post right now. But if you go to the core courses, you're gonna be able to see the lab posts. Let me go to labs and post lab 15. Lab 15, lab 15, submission type, and then feedback, submission settings. And that's also due on the 13th. Excuse me. And save and display. Blah. There, click on, click on. Oops, 13. Save and display. Let me share my screen. Okay, so if you go to the last part of the courses, you go to the bottom, you're gonna be able to see the two new labs that are due. You're gonna work on it today, lab 14, and on Wednesday also on your own. We don't have class on Wednesday, but we're gonna be checking off your labs on Friday. Lab 14, lab 15 on lecture. We don't have lab on Friday, but we're gonna be checking them off on your lecture time. Okay, so make sure you have them ready before class because um, you probably won't have time to do them there, and we're expecting them to just check it off. So make sure you work on them and you have them ready before lecture time on Friday, which is the 1:30. Okay. If you open it up, you're gonna be able to see the instructions for the lab is that you're gonna design a circuit that it requires 4 inputs X, Y, Z, W. When the binary inputs 0, 1, 2, 3, 4, 5, 6, 7, 8. Let me start 7. You're gonna be able to. The output will be 1 greater than the input. When you have binary numbers, input 8, 9, 10, 11, 12, 13, 14, 15, the output should be 1 less. I'll show you guys an example, or I'll show you guys my work. That way you guys have an idea. And that's for that one. The second one, 15, is the adder lab, which is you're going to be designing a circuit where you add them together. Where you add, if you were to add two binary numbers, sorry, 4-bit binary numbers with 4-bit binary numbers, you're going to be able to get the result back. Okay? So you should be able to have that. You should be able to work on that part. So here, I'll show you guys that one's going to be a little more complicated. She was working on it in class, in lecture, so you should have an idea on how to start that part. I'll keep working on it and showing you guys in the background because more likely you won't be able to finish them, but at least you're gonna be able to have an idea in the background. Or if you already know what to do, you can just straighten work on it and just ignore me. Or if you have any questions, you can always put your name in the chat. Or if you need to check out something, also put your name in the chat. Okay, and I'll show you guys. I'll show you guys my work.
So wait, we're just working on this Carnot map thing?
Yes, you're working on both of them. The lab 14, lab 14 and lab 15,
Okay.
the kernel map, but you have to do the circuit design also.
Okay.
For both of them. So do the table, do the kernel map, and then do the circuit. Practically, what we're going to be checking out is your circuit, but you cannot do your circuit without doing the table and the kernel map. The kernel map, you won't be able to do it without the kernel map.
Yeah, to set it up.
Yes.
Yeah.
And so let me share my screen so you give you guys an idea of how to get yourself started. So here is my table. So I did it on Excel just so I can present to you guys. So here is the inputs, the 4 inputs. Here's the integer value. Okay, and this is the binary value. So here's 1, this is 2, this is 4, and this is 8. Right, so here we get 0 because this is saying that the instructions are anything between 0 and 7, where the output is going to be 1 greater than the input. Okay, 1 greater. So if I have a 0, my as an input, my output should be 1. And that's what we have here. 1. And then if I have a 1, my output should be 2. And that's what we have. We have a 2. And then if I have a 2, my output should be a 3. We have a 3. We have a 3 because we have 1 plus 2 equals 3. 0 plus 1 plus 2 equals 2. 1, 1. And so on. So you can see that I'm adding 1 to every single input from 0 to 7. So this is a 3, that should be a 4. That's what we have, 4. This is a 5 because my input is 4. And then a 6. And then a 7. And then my last one is a 7. my output should be an 8. Then once we get to the 8 and 9, my instructions are to, so once I get to input A9 all the way to 15, my instructions are that I'm going to subtract 1 to the input. So that will be my output value. So for 8, I should get 7. That's 7 right there. For 8, or for 9, I should get 8, and that's what we have there. And then for 10, it's 9. For 11 is 10. For 12 is 11. For 13 is 12. And then for 14 is 13. And for 15 is 14. So you can see,
Professor,
yes. Oh, sorry. Yes, sorry.
uh,
Go ahead.
where will this recording be posted? Will it just be posted under the lab?
I can, yeah, I can post the recordings. But I mean,
Yeah,
actually,
please do.
I'm not sure because I'm actually showing all the work, so I would want you guys to do it. Um, this is showing everything. I mean, I want you guys to try it. Um, hmm. See, it's weird because I don't want you guys just to copy the answer. Um, I have to think about it. I can. Okay, I'll post this, but the circuit it will be up to you guys. Like you guys should be able to have an idea uh, I'll be able to translate this into the circuit. So yeah, so this is fine. You can check your solutions here, and then to be able to do the circuit, well, it's gonna be here, this part right here. So be able to translate that into the circuit. But yeah, I guess I can post this one, and that should give you guys a good. Okay, yeah, I can post it. I'll post it underneath the lab 14.
Okay, thank you.
Mhm. So 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 you can see right here, you have one less between 8 and 15. So now what you do is you want to translate that into a map, into the kernel map, and uh, so this will be your M0, M1, M3, M2, M4, M5, M7, and this is not a mistake. This is how it is. On here, we put it backwards, and the reason is because when we fold them, we want them to be together. Otherwise, they wouldn't be able to be together. Like you want to be able to group these guys together, and you want to be able to group this guy and this row together. So that's why we put them. We switch this two columns and like that. So this is not a mistake. This is the way it's supposed to be. Okay. Um, so we put the values, right? So here for A, I'm gonna focus on A. I want to figure out what the function value for the A is. So I'm gonna put my values. So this is 0 for M0. So it's 0. M1 is, so I'm gonna make this guy right now white. Just so that we don't get confused. And okay, so we're looking at this row right here, and we're looking at M1 now. M1 is going to be 0. M2 is going to be 0.
Oh, you're not sharing your.
Oh, sorry. There you go. So again, so this is your table right here. So this is not a mistake. This is the way it is. And the reason is because when we fold these guys, we want to be able to fold them and these guys to be connected. This guy, this row, and that row are the ones being connected. When we fold them in the middle, right here, right there, when we fold them right here, they can be attached. So now we go through here and we have M0 is 0, and that's what we have here. M1 is 0, which is right here. And then M3 is next, so M3 is 0, and that's 0. And then M2 is 0, and that goes right there. And then now M4. So we go to M4, that's 0. M5, it's 0. And there's M7, it's 1. And then we go back to M6, and that's 0. And then we go to M8, which is down here. So again, this also changes right here, right? So we skip this the M8 and we put the M12, and the reason is because we want to be able to group these guys together, and these guys are being grouped with these guys. So when we fold it in here in the middle, if we were to fold it right in here on this line, we can connect those two and connect the M8 and the M0. That's the reason. So we look at M8, and M8 is 0. M9 is 1. M11 is 1. M10 is 1. And then we have 12. We have 1. And then we have 13, 1, 14, 1, and then 15, 1. So that's how you make this one. Now, how to be able to make this function right here is you try to connect as much as possible, but you can only connect in either groups of 1, groups of 2, groups of 4, or groups of 8. So let's see, we can actually make this one group right here. So I'm going to highlight that. Oops, wrong. So that's 1 right there. So we can group these guys together. And to be able to represent this, we look at this guy. So it seems like the only thing that is not changing in here, the only thing that's not changing in this group is the X and the Y. So it's going to be X, Y. So that's my first group of variables. Anything else changed? This guy's changed in here, between here, here, and here. So there's changes between the 0 and then between the W, the Z and W, the Z and W, they change over time. The only thing that does not change in this group is the X and the Y. So that's why we have an XY there. Now let's look at another group. We can do this group right here, and let's paint it red. So here's another group. Now we look at this group, and we see that the only thing that's not changing in the X and Y side is the X. So we get the X. Now we look at the horizontal part of it, and the only one that is not changing is the W. I think okay, that's the other one. The W. So that's supposed to be this one right here. XW. So the X did not change and the W did not change. So we have this one, XW. So now the next one we can group is probably right in here. We can group these guys together and put them together. And you're probably thinking, wait a minute, why are you overlapping? Why are you trying to overlap or trying to do things that you already overlap? Well, the reason is because you're going to use less variables if you use a bigger group. It doesn't matter if you're overlapping, that's fine. But the ideal thing is you want to use it as